Hello students, let's see another question which came in GATE 2020 Civil Engineering. This was question number 46 in the afternoon session. So the question states that a footing of size 2 meter cross 2 meter transferring a pressure of 200 kilonewton per meter square is placed at a depth of 1.5 meter below the ground as shown in the figure. This is the figure. The clay stratum is normally consolidated. Point toward normally consolidated clay. The clay has a specific gravity of 2.65 and a compression index of 0.3, and some data is given in this figure. Considering a 2:1 vertical to horizontal method of load distribution and gamma W, that is unit of water, as 10 kN per meter cube, the primary consolidation settlement in mm, round off to 2 decimal place, of the clay stratum is asked. The reference to solve this question could be found out in the lecture 39, Compressibility of Soils, in the course of Geotechnical Engineering 1 by Professor Dilip Kumar Baidya, Department of Civil Engineering, IIT Kharagpur. So first let us see what all data is given to us. Size of footing as 2 meter cross 2 meter. Depth of the footing is given as 1.5 meter. And it is given as normally consolidated clay, whose specific gravity is also given as 2.65, and the compression index is given as 0.3. So we have to find out the settlement of the clay layer, that is primary consolidation. So it would be calculated using the formula delta H comes out to be Cc H naught 1 plus E naught log base 10 initial effective stress plus increase in effective stress divided by initial effective stress. So to find out the delta H, we have Cc, we have H naught. We need to find out this initial void ratio and these effective stresses. So to find out the initial void ratio, we could use this value, that is gamma saturated is given to us. So using that, gamma saturated, which is given as 17, is equal to G plus Se gamma W whole divided by 1 plus E. We have G comes out to be 2.65, S would be 1, so E times gamma W, it is given as 10 divided by 1 plus E, which is equal to 17. If you solve this, you would get as E comes out to be 1.36. So now let us calculate the initial effective stress at the mid of the clay layer. So here we have to find out the initial effective stress. So for that we could use the figure and get the data. 1.5 meter, that is this depth, into 15 is the density, plus this 0.5 meter would be 0.5 into 15, plus this is given as 18 gamma saturated. We need to find out the effective, so 18 minus 10 into 0.5 plus this is 17. This would also be effective, so 17 minus 10 into mid of the clay layer would be 1.5 by 2. If you solve this in calculator, you would get it as 39.25 kilonewton per meter square. So now we have this also, this also, this also. Also, only we need to find out the change in the effective stress at the mid of the clay layer. So as in the question, it is given as the 2 vertical to 1 horizontal. So for every 2 unit increase in the vertical depth, 1 unit is increased in the horizontal direction. So at the mid of the clay layer, we would be having this at the mid of the clay layer. This would be 1 and this would be 0.75. So for every 2, we have to increase 1. So for 1.75, we have to increase by 1 by 2 into 1.75. This is in one direction, which comes out to be 0.875 in the one direction. So this need to be increased in the both direction, this and this. So total increase in the width would be 2 times of 0.875, which would be equals to 1.75. So the initial footing size, that is given as 2 meter by 2 meter, would change to 2 plus 1.75 cross 2 plus 1.75. which would be equal to 3.7 cross 3.75 cross meter. So the change in the effective stress would be equal to 200 into initial size 2 into 2 divided by the size at the mid of the clay layer 3.75 into 3.75. If you calculate this, 56.88 kilonewton per meter square. Now let us put all the data what we have calculated. This is 0.3, which is cc, and the height of the clay layer is 1.5 divided by 1 plus void ratio 1.35. This we have to take the log initial effective stress 39.25 plus increase in effective stress 56.88 divided by the initial effective stress 39.25, which comes out to be 0.0745 meter. So in mm, this would be 74.5 mm. Let us see in what unit the answer is asked. The answer is asked round off to 2 decimal places in mm. So this would be 74.5 mm would be the correct answer. Thank you.